Hello, everyone. This is our first real lecture. What we did last time was just revision for equations of a straight line. So what are we going to learn in this semester? In this semester, we're going to learn about two important subjects in physics. One of them is motion from mechanics, and the other one is about electricity. We will start with our first course, our first part of the course, which is motion. Everything around us moves. Planets move, birds move, animals move, ants move, fish move. We move in many different ways. Actually, not only things around us move, also things inside us move. An example of that are red blood cells, for example. So this is a very important topic in physics, and this is why we are covering it this semester. Important notions that we will be covering in this exact lecture are displacement, velocity, and acceleration. Displacement has to do with how far one can go from one place to another. Velocity, how fast one can go. Acceleration, are we going at the same velocity or are we changing our velocity? I know for now this sounds very difficult for you, but it will get easy during the lecture. Just a second. Yeah. So motion can be in many ways, but we will start by making our life much easier. We will start by motion in one and only one dimension. It can be like this guy over here. He is moving along this horizontal path. It can be like this guy over here. He's skiing along a slope, or like a rocket, which goes up and down. In all these three cases, the object moving is moving only in one dimension. And this is the first chapter we will be dealing with. Motion in one dimension. Okay? Position of an object. Take an object found at point A. Okay, let's consider an object located at point A, over here. If I ask, what is the position of point A? What is the position of point A? It's just a point on this screen. In order to say where exactly the point is, I need to define few things. One of the things I need to define is an axis, to say that this point is along this axis. In this case, I called it an x-axis. We need to define an origin, that this point A is far away from point O1 or from point O2 or from point O3 or point O4. You can put it anywhere you want along the axis. We also need a scale. That is, this point is far away from O2 by 2 points, where the scale is from here to here. Okay, now, what is the position of object A? If the origin is O1, then axial A is on O1. So axial A is 0. If the origin is at O2, over here, then axial A will be +2, because it is located 2 points toward the x-axis away from O2, toward the positive x-axis. However, if I take O3 to be my origin, then I find that point A is minus 3, because it's in the opposite direction to the x-axis, it's minus 3, right? So it's minus 3. Over here. Now, this is about position. So in order, again, in order, just a second, making sure it's recording, yes. In order to find a position of an object, I need to define 3 things: x-axis, origin, and scale. Depending on the origin, the x of the position of x, we mean by it the position. Okay, so x is the position. X of point A will change depending on the origin. Let's start then by displacement, because I told you in this lecture we will cover displacement, velocity, and acceleration. Displacement. Displacement of an object. When an object moves from one place to another, it gets displaced. Actually, this is the proper English meaning. That is, if I'm living in Lebanon and I move to whatever, UK, then I am displaced from Lebanon to UK. Okay, so this is the proper meaning by displacement. It is the motion from one place, it is a displacement from one place to another. In this chapter, by displacement, we will refer to it by delta x, and it is x final minus x initial. By xf, I mean final position. By xi, I mean initial position. So displacement, delta x, is x final minus x initial. Let's give an example. This is an example over here. Over here. Let me make it clearer. So I'm talking now about this example. Okay, there is a point that was at point O. There is an object that was at point O, and it moved to point A. It moved from point O to move toward point A. And I want to calculate the displacement. So displacement is delta x. I will just write delta x. It is x final minus x initial. X final here is x at O, at A. Sorry. X final is x of A. X initial is x of O. So delta x is x lal A minus x O, which is equal, what is XA according to this x-axis and this origin and this scale? It's 1, 2, 3, 4 to the right. So it is plus 4 minus x at O is 0. This is equal 4 centimeter. It's very important, the unit, by the way. Displacement has the unit depending on what I put on the x-axis. So this is here unit centimeter. So the unit of the displacement is centimeter. Physics is not math. In math, we deal with numbers. In physics, we deal with numbers and the proper units. Okay, so displacement has the unit of distance or of distance, which is centimeter, meter, kilometer, depending on what we give as the unit of the x-axis. Now, displacement in this case, the XA minus XO, give us 4 centimeters. Now, if you just use your brain, I mean, what distance means? Here, if I want to say, how much is the total distance covered by this object that moved from O to A? How much is the total distance covered? It went from O to A, it covered 4 centimeters. So in this particular example, displacement and distance are the same. Now, let's take another example. Another important example over here. Again, what's happening here is there is an object that started at O, went all the way until here. then went all the way back until point A. Okay, so it went first all the way until here, and then went back until point A. Okay, so what is displacement? Again, displacement is x final minus x initial. X final is x of A, x initial is x of O. So this is equal. What is x of A? X of A is here, it's plus 2, minus x of O, which is 0. So this is 2 centimeters. Now, what is the distance covered by this object? Is it only from 0 to A? No, it went all the way till here, then all the way back till A. So in total, how much is the distance covered by this object? It went 4 centimeters first. Look, 1, 2, 3, 4. I'm not sure if you can see my mouse. You can see my mouse. It went 1, 2, 3, 4, plus 1, 2. This is the total distance covered by the object. So it went 4 plus 2, which is 6 centimeters. Let me give you another easy example. Let's assume someone started in Tyre, in Sur, okay, in Sur in Lebanon. He went all the way to Beirut, which is like 80 kilometers. Then he went back to Saida. How much is the total distance covered by this person? If he has on his car a pedometer to measure the distance, how much is the total distance? It's all the way to Beirut plus from Beirut to Saida. So that will be 80 plus 40, I think, from Sur to Saida. Okay, is it clear? However, if I look at only the displacement of this person, he went from Tyre to Beirut, then from Beirut to Saida. His final position is Saida. His initial position is Sur. So the displacement is 40 in this case. Okay, so the distance and displacement are not always the same. A last example is here. This last example over here. This is an object that moved all the way till here, then all the way back. Okay, what is the displacement? If you just forget about all the way it went here and back. If I look at this object, it was at O, now it is at A, which is exactly at O. So how much is the displacement? It is XA minus XO, but XA is 0, XO is 0, so delta X is 0. Displacement is 0. It's as if it didn't move. It's as if it didn't get displaced. Again, it's like someone started in Sur, came to Saida, went to Beirut, then came back to Sur. How much is the displacement? It's from Sur to Sur, so it's 0. However, how much is the total distance covered by this person? This person went all the way to Beirut, then all the way back to Sur. So it is double the distance from Sur to Beirut, right? In this case, which is 4 centimeters, it's 4 plus 4, it's 6. Okay. Okay. Now, an example, a car moves from position A to position B as per the following figure. Find the displacement. It goes from point A to point B as per the figure. So how did it go? It went this way, right? Find the displacement. So the displacement, delta X, you can just put delta X, is final position, which is point B, so it's X of B, minus X of point A, which is 5. This is the origin O. So it's 1, 2, 3, 4, 5. Second, let me show. It's 1, 2, 3, 4, 5. So it is 5 minus X of A, which is 1, 2. 5 minus 2 is 3 centimeters. Okay. Displacement can be positive or negative. It can be positive if I'm moving along the positive x-axis, as in this case. But it can be negative if I'm moving against the x-axis. I will give examples on that. But for now, I just want you to keep this in mind, that displacement can be positive or negative. In this case, it's positive because it's along the positive x-axis. Distance, however, distance is not a quantity which has to do with direction. Distance is a quantity. It's the total distance covered. In this particular example, distance equal displacement equal 3 centimeters, but it's not always the case because distance is always positive. It is a scalar quantity. We say it's a scalar quantity. It's a quantity which is always positive. What's another example of scalar quantity? Another example is it's our weight. It's our the measurement we get on when we weigh ourselves on a scale. For example, 70 kilograms. This is a scalar quantity. Okay. Okay. Now let's start by solving some examples from your booklet. So you need to open page 1, example 1. Use the figures in the table below to calculate the displacement and the distance traveled. So we want to calculate distance, displacement, and distance. Okay. So let's start by the first example. How much is x initial? Sorry. How much is x initial? It's 10 centimeters. X final, 80 centimeters. And it went, sorry, just a second. Okay. It went from x initial 10 centimeters to x final 80 centimeters in this direction. So displacement equal 80 minus 10 equal 70 centimeters. And because it's with the positive x-axis, it is a plus 70. Actually, 70 or plus 70 is the same. Now, how much is the distance? It's exactly the same as the displacement. All right. The other example, B, x initial is minus 10, x final is 6, delta x equal x final 6 minus 10 equal plus 16 centimeters. So distance, okay. So displacement equal plus 16 centimeters. Also distance here is equal to displacement because it's moving with the positive x-axis. Third example, a ball moves from x initial 80 centimeters to x final 20 centimeters, but it's moving in the negative direction. So displacement equal x final 20 minus x initial 80. So we get minus 60 centimeters. It's normal because it's going in the negative direction. However, how much is the distance? We don't say here it is negative 60. Distance is always positive. So it is 60 centimeters. Last example, I leave it for you to do it yourself. Here's the solution. This is all I want to say about displacement in one dimension. Now we come to the notion of velocity. Let's take these 3 cases. This mouse. Okay. Let's take these 3 examples. There is a car in all cases that went from Saida to Beirut. Okay, went from Saida to Beirut. In all the examples, from Saida to Beirut, from Saida to Beirut, from Saida to Beirut, which is around 40 kilometers. The displacement is around 40 kilometers. Okay, but one object took 2 weeks to arrive. Let's not say it's a car. Let's say any 3 objects, they're going from Saida to Beirut. For example, the first one can be, I don't know what, an ant or something very slow. So it took 2 weeks to go from Saida to Beirut. The other object took 10 hours to go from Saida to Beirut, and the third object took 1 hour to go from Saida to Beirut. What are we varying here? Here, the displacement is the same. What are we varying? We are varying the time. So speed or velocity, we are used to say the word speed, and we use speed and velocity as being the same concept. They are not. Over here, we will make we will distinguish both speed from velocity. Velocity or speed, it's how much the distance is divided by the time it required. So what we usually say speed, we will call it V average. It's over here. It's total distance divided by total time. Okay, so this will be speed. This is like distance over there. Over there, in the previous slide, we said displacement and distance. Here we will say velocity and speed. Speed is total distance divided by total time. Velocity is displacement divided by total time. Okay. Let's take an example directly so as you can understand what we're talking about. So this is an example also from your booklet. During a race, don't worry much about the English. So I will focus on the important things here. During a race, on level ground, Jad runs with an average velocity of 6.02 meters per second. So what is this? Average velocity. So I directly write it over here. This is the average, 6.02 meters per second. The question is, what distance does Jad cover in 137 seconds? So what is this 137 seconds? What is it? It's time. This is delta T. Okay. So I have the average, I have delta T, and I want to calculate the distance. So what do we use? We use V average equal total distance over total time. And I simply put the values in their places. So V average is 6.02 equal distance over 137. Here, I don't worry about the units because this is seconds, so I don't have to change anything with the units. Now I just do cross multiplication. Distance equal 137 times 6.02, and I get the value. Okay. Another example. If Joe rides south on his bicycle in a straight line for 15 minutes. So what is this for 15 minutes? What is this 15 minutes? This is delta T. Okay. With an average speed, so this is another important information, of 12.5 kilometers per hour. How far has he ridden? How far? How far means distance. Find the distance. Okay. So how far means how much is the distance. So what do we use? Again, I have the average, I have delta T, I need distance. So I use the average equal total distance divided by total time. Here I have to pay attention that delta time is given in minutes and the average is given in kilometer per hour. I cannot use two quantities in one equation where one of them is minutes, the other is hour. I have to do change in units. How the easiest way to do this one is to change minutes to hour. How many hours are there in a minute? Or how do we change minute to hour? We divide by 60. Okay, we divide by 60 because 1 hour is 60 minutes. So 1 minute is what? So 1 hour is 60 minutes. So 1 minute is 1 hour over 60. So I divide by 60. I divide, so it's 0.25. Now I have proper units. So V average equal total distance over total time implies distance equal V average times time. V average is 12.5 times 0.25. This gives me 3.125 kilometer. Why is it kilometer? Because this is the unit of the average given. If it was meter, I would have used meter. Okay, so this is about velocity. Last notion for the day, and we're almost done, is acceleration. It's very rare that someone can go from Sur to Saida at the same speed. Like if he starts at 70 kilometer and he remains at 70 kilometer the whole way. Usually what happens, it's either he will start at some speed and speed up, or it will speed down, okay? So this change in speed is acceleration. And just like V average and V, A average is V average over time, and A is delta V over delta T. Okay, so this is similar to what we saw in the previous over here. V average is total distance over total time. V is delta X over delta T. When it comes to acceleration, A average is V average over time. Acceleration is delta V over delta T. Acceleration can be positive or negative. If the car is speeding up, acceleration is positive, just like in this example. If it's speeding up, acceleration is positive. If it's speeding down, acceleration is negative. However, A average is a positive quantity. Okay. Now, let's do examples on that. Also, it's from your booklet. A car traveling at 7 meters per second. So what is this 7 meters per second? It's traveling at 7 meters per second, accelerates at 2.5 meters per second square to reach a speed of 12 meters per second. So what are these things? This unit here is meter per second. So this is like distance over second. So this is a speed quantity. This is a speed quantity. And it started with it. So this is V initial. This is V initial. Now, 2.5 meters per second square. So the acceleration is 2.5 meters per second square. So this is the acceleration. To reach a speed of 12 meters per second. So this is V final. And the question is, how long it takes? How long? يعني قد ايه بدها وقت? How long يعني بدي طلع delta T. So I will use A equal delta V over delta T, which is V final minus V initial over delta T. Acceleration, notice here, this is in meter per second square, meter per second. I don't need to change units. Everything is in the same unit. I don't see hour somewhere and kilometer somewhere, which is not everywhere, okay? Now, instead of A, I will put 2.5. Then V final is a 12 minus 7 over delta T. Cross multiply. 2.5 delta T equal to 12 minus 7, which is 5, implies delta T equal 2 seconds. Okay. Okay. Last slide, another problem from your booklet. With an average acceleration, so let's put this again. With an average acceleration of minus 0.5 meters per second square. Why is it minus? because it is decelerating with an average acceleration of minus 0.5 meter per second square. Decelerating means it's speeding down. يعني بلشت بسرعة كبيرة وبلشت يبطئ. How long مثل السؤال اللي قبله، يعني بدي اجيب دلتا تي. Will it take a cyclist واحد عم بيسوق بسكليت to bring a bicycle with an initial speed of 13.5 meter per second? So this is the initial speed, 13.5 meter per second, to a complete stop. What does it mean, complete stop? What does it mean, complete stop? It means V final equal 0. So again, I have acceleration, I have a V0, V initial, V final, and I want to get delta T. So I use the same equation, A equal delta V over delta T. A is minus 0.5, delta V equal V initial, sorry, V final 0 minus V initial 13.5, so it's minus 13.5 over delta T, which I want to find. I do cross multiplication again, minus 0.5 delta T equal minus 13.5, delta T equal 27 seconds. Why it is seconds, not minutes or hours? Because it is seconds everywhere, okay? So it is seconds. So this is all about displacement, velocity, acceleration. One thing I have just realized that I forgot to mention in this presentation, but I'm gonna add it. I'm gonna add one slide on units. One thing you need to know, that displacement has the unit of distance, that is centimeter, meter, kilometer, decimeter, units of distance, okay? Velocity, which is displacement over time, it has the units of meter per second, because it is distance over time, so it is meter over second, or kilometer over second, or kilometer over hour. So it has the units of distance over time. And acceleration, it is speed over time, so it is meter per second, so it's meter per second square. And that's why you see that acceleration is in meter per second square, whereas velocity is in meter per second, and distance is in meter, time is in second or hour or minute, depending on the given problem. Okay, so I'm gonna add a slide speaking about the units. Okay, this is all for today's lecture. Tomorrow I will have another lecture, and we will have our live session, class time. See you tomorrow.